Good afternoon, everyone, and thank you for joining us for today's webinar. My name is Jean-Pierre Picard, and I'm Product Marketing Manager at CML Labs, and I'll be your host today. Today's presentation will last approximately 45 minutes, after which we'll have an open Q&A session. With me on the line is Marc-Alexandre Vézina, Product Manager for Vortex Software Solution, and also in the room to take your questions during the presentation is Frédéric Picard, our Arts Director, who is probably the most knowledgeable person about today's topic, which is the Vortex Graphics Gallery. So this is your occasion to send your tough questions about Vortex Graphics Gallery and creating vibrant visuals in Vortex. Now, this webinar is part of our Vortex University webinar series, which is a monthly webinar series in which we take one specific Vortex topic and then we do a deep dive on it. And we go into details about the different features, functionalities, or steps to take to achieve a very specific outcome in Vortex. Today's presentation will focus on the graphics gallery. Now you can use it to create graphics material, apply them to models, and use this model to create your scenes and mechanism. So we're going to go through a process that will outline all of this. The presentation is split into 4 broad sections. We're going to start by talking about importing models, how you can import models, which types of models can be imported into the graphics gallery. Then we'll talk about the work you should do cleaning up and optimizing your model's graphic nodes before you start working on the visuals and graphics materials. Then we'll spend a good amount of time talking about graphic materials. What are they? How do they work? How can you use those to create realistic equipment and realistic? And finally, we'll talk about how you can go from a graphics gallery to a functional mechanism. I've mentioned that we'd have a Q&A session at the end of the presentation, but if you have questions at any time or issues with audio or visuals, simply use the right-hand side questions box and let us know. You can also download today's presentation using the handouts menu on the right. Now, we are recording this presentation as usual, and we'll make it available on our YouTube channel in the next 2 days. So if you want to share the presentation or review some of the content, you'll be able to do so. For those of you who are not familiar with Vortex, just a quick recap about what Vortex is. Vortex is CM Labs' real-time visualization and simulation platform. It includes creation tools, it includes the dynamics engine and the visualization engine necessary, as well as the integration capabilities to create full-blown simulators. And these simulators can be used for virtual prototyping, and that is product teams that use a virtual model of their equipment to test their performance before going on to a physical prototype. Vortex is also extensively used for operator training in a wide variety of industries such as construction or port crane operation. And it's also used to prepare missions and rehearse missions in a variety of industries, be it heavy load planning or subsea deployments. Now, it's deployed and trusted by customers in a wide range of varieties worldwide. Today's demonstrations will use the Vortex editor, which is the desktop-based application of Vortex Software Solution. It's used to create, validate, and prepare your Vortex simulations for deployment. It includes a built-in desktop simulation environment in which you can validate your simulations before you move on to your final simulator. All right, so today's topic is the Vortex Graphics Gallery. Before we move on to the process of importing a model and creating graphic materials, I'd just like to talk about what the Graphics Gallery is. So it's a Vortex editor document type. It's on the same level as the assembly or as the mechanism. So it's a document type you can create in the Vortex editor and then connect with other parts of your simulation. It allows you to manage model hierarchy, so that is the graphics node, but also the geometries, graphics geometries, the mesh, textures, and the graphic materials used by your simulations. It was added to Vortex in 6.6, and it's being expanded on in Vortex 6.7. In fact, today you're going to get a sneak preview of some of the new capabilities of Vortex 6.7 because we'll be using the latest build to talk about multi-texturing, which is a feature that's coming with 6.7 that is going to be released in the next few weeks. So what's in a graphic gallery? Well, in a graphic gallery, you're going to find first graphic nodes. Graphic nodes are there from the import of your model, and they're the different parts of your model, basically. Now, your graphic nodes can have graphic geometries attached to them, and that is mesh. The mesh represents the visuals volume of your model, and it's on that it will unwrap our graphics materials to dress up our model. Graphic materials are the clothes of our model. They are a set of textures and masks that are layered on top of each other to create sophisticated visuals that we then apply to the graphic mesh. Now, textures are the base building materials of our graphic materials, and they, as you will see, they are used in a variety of channels to affect how our graphic materials will look, and by extension, what our final equipment will look like. The graphics gallery is used in two other entities the first one is with mechanism, and that is what it is most known for. The graphics gallery is imported into mechanism to enable the creation of parts and then further along constraints. But it can also be used in scenes, and it provides you with more control over how your scene looks, but it also allows you to modify the scene by copying node and moving them around without going back to an external software for 3D modeling. So that is a more or less known application of the graphics gallery that is extremely convenient. All right. So now that we are clear on what the graphics gallery is, we're going to begin the process of creating a model in a mechanism in Vortex by importing our model. Now, before Vortex 6.6, we used to import models directly into the mechanism, and you had to import a 3D model. You also had little to no control over the hierarchy and visual aspect of your model. So since then, in 6.6, we've also added support for CAD models. Now, these are extremely popular for users who want to create virtual prototypes, so they can go directly from engineering-grade CAD assets to a Vortex mechanism. It does require the CAD Optimizer add-on license, which is available as an optional purchase. From a file types perspective, we support 4 3D modeling file types. OSG, IV, and flight models have been supported for quite some time, and 6.6 saw the addition of the very popular DAE pipeline. On the CAD front, we support 3D XML, STEP, JT, SolidWorks, and STL out of the box with the CAD Optimizer add-on, but please note that if you need other file types, they are available on request, so make sure to talk to your Vortex representative. So when you import your model, the first thing you want to do is you want to organize its hierarchy and optimize it. The graphics gallery comes with a feature set that allows you to manage your graphics nodes and the meshes that are attached to it. So you can do things such as reorder nodes, remove empty nodes, or set their transform. You can also merge or split nodes. Now, if you own the CAD Optimizer add-on, you will also see an extra set of tools in the graphics gallery that allow you to defeature your CAD model, because CAD models will typically come with a lot more details than is necessary for real-time simulation. Things such as nuts, bolts, and holes that don't affect the performance of your equipment will tax the memory of your simulation, the efficiency of your simulation. So with the CAD Optimizer add-on, you get to simplify your model and make it ready for real-time simulation. If you want to see those tools in action, I invite you to go to our YouTube channel where we have a previous Vortex University session that goes over this tool set. All right, so we're going to step right into the Vortex editor with Marc-Alexandre, who will show us the different tools available to optimize our model. Marc-Alexandre.
Thank you, GP. So to save time, I've already preloaded a model, but how to get there was very simple. I went to the new file, I opened a new graphic gallery, then I used the 3D button here to import my model. So in the left side panel here, which is the Explorer panel, you can see that you've got your graphic gallery, you've got your nodes, you've got your geometry, which are the mesh from which the model is composed, the graphic material and the texture. The graphic material and the texture, we're going to look at them a little later. For now, let's concentrate on the nodes and the graphic geometry or the graphic mesh that compose the model. So if we expand the hierarchy, we see that every part of the model is composed of nodes. And these nodes can be manipulated and moved inside the hierarchy to reestablish the parent-child relationship. Right now, if I move the parent here, the entire model will move because everything is under it. If I try to move only the wheel, then only the wheel will move. It's possible to reorder them on the fly. So for example, if I move the main mesh under the wheel and then I grab the wheel, it will now move with it. We mentioned earlier some tools that are available to manipulate the node. The first tool that I want to show you is the remove orphan tool. What the remove orphan tool does is that it takes out all the unused geometry, texture, and material in the model so that you can end up with only what you're actually using in the final simulation. So I click on it and it gives me a list of texture and material that are not being used. So I can just click on delete all and remove them from the model. I can also delete nodes directly from the hierarchy. So for example, here I've got a node that has no graphic material and no graphic geometry. So it's just a transform that's hanging there with a hierarchy underneath that's also empty. So I don't need this in my final model. So I'm going to just use a delete key and simply eliminate it from the hierarchy and make it much simpler. And you can do this with any graphic node. For example, if you in your model have a graphic node for the transmission, for example, and you don't need it in the final model because it's hidden inside, you can just drop the node and make a lighter model. The other tools that we have in the panel up here are a bake graphic node. What bake graphic node does is that it takes a transform that already has some modification in it, and then if I select the bake graphic node, it resets everything to 0. So it's fairly useful if you have a transform that's been moved or adapted from something else. Other tools that we have is a tool to merge graphic node together. So for example, if well, for this case, they're wheels, so it doesn't really apply, but I'm going to grab the wheels. I'm going to say, well, I'd like to merge them together to make just one node. It's important to consider that you can only merge nodes that have the same graphic material. So if you select nodes that have different graphic material, the merge operation will fail. So right now I've got 4 different nodes, and I hit the merge graphic node button. And now there's a new node that's been created that's called merge of all the parts, and I can rename it to whatever I need. So forward wheel set, for example. And the previous nodes have been eliminated from the hierarchy. And I can also run the remove orphan again, and as you can see, all the mesh of the nodes that I merged together are now not used, so I can delete them, and I have a new mesh that's been created for this one. That's called merge geometry to do the rest. Other tools that we have in our toolbox, set transform to center. What this does is that it moves the transform to the center of the part. So if you have a wheel, for example, and the transform is at the origin of the whirl or the origin of the vehicle, but you need the transform to be centered for your mechanism, you can just click on the set transform to center and it will move the transform to the center of the node. In this case, the center position between the 4 wheels. Now let's say that I wanted to have a transform in a wheel, for example. There's a way to do this by adding a node, an empty node to the model. So I go grab, and then what this does is just add an empty node, which I can place anywhere. So I'm just going to use the bake again to remove all the transforms. So it's there. I'm going to place it wherever I want. So let's place it, for example, here at a rough position like this. Now my transform is at the middle, but I really want it to be there. So what I can do is use the set graphic node transform here, and I'm going to select another node, and then the transform is going to be moved to the new position, and then I can just go back to my original node and delete it. So you can go on like this, and when you receive the model, create a hierarchy that will make sense. You can rename the node, you can reparent the node in order to create a model that's going to be easier to transform into parts, and finally, which is going to be simpler and lighter to use in your simulation. Back to you, GP.
Thank you, Marc-Alexandre. So now that we've imported and prepared our model for fine-tuning and then creation of the mechanism, we're going to look at graphics materials now. Graphic materials are going to be one of the meatier sections of this presentation. Before we look at how you create a graphic material, let's define it. A graphic material is a set of textures and masks applied to those textures, as well as a group of properties that you then apply to graphic nodes. Now, graphic materials can be comprised of multiple texture layers that are applied on 6 different channels. So we're going to go through these channels in a moment, but just a quick word on the properties panel. So the properties panel for graphic material shows you a preview. In that preview, you could switch to different shapes, and it provides you with a dynamic preview of what your graphic material looks like. You then have a set of properties that allow you to control the blend mode of your graphic material, but also whether it reflects the environment or not. Now, a quick caveat on that is that environmental reflections are restricted right now to the skybox and skydome. But if you do turn on environmental reflection on a graphic material, then it will reflect what's shown in the skybox at that time. Then you have your channels, and each channels, as you can see in the screenshot, can be expanded to show the different layers that are part of it. Now, the layers can include textures and masks, as well as base colors. So each of these will be layered on top of one of another, and masks will define which parts of a texture shows through. Textures are imported into graphics gallery, and one quick note is that in Vortex 6.7, we will now support up to 4 UV set per texture. If you're not familiar with UV sets, they represent the way you unwrap your texture image on your graphic mesh. So it's it's something that basically you can use to control how your model will look without having to create separate textures. Now, textures can be instanced with different properties without being loaded twice. What we mean by that is that you could create a copy of, let's say, this texture here, then change its UV settings. So have a different number of tiling instances on the same mesh, change its angle, or use a different UV set. Because it's instance, it will not decrease model performance. So you can see your texture in the properties panel, and you can see the UV properties as we've discussed here. You can also see the size of your texture and the amount of memory it will take once you run your simulation. And you can control other parameters at the bottom of your properties panel. So I've been mentioning that you could layer textures on top of one of another. That is true in Vortex 6.7, which is coming out in the next few weeks. And what you'll be able to do is you will be able to layer textures and masks on top of one another in different channels to achieve better looking graphic materials with smaller files. How it works is that you begin with a texture. Now in 6.6 and before that, that's the only texture you would have, and that would define how your graphic mesh looks. In 6.7, you can add a second texture on the same channel or on different channels, and then apply a mask on it that will define which portion of that texture will be displayed and which will let texture 1 show through. The result is a combined texture that will provide more sophistication and will look nicer, but will also most likely be smaller and provide better performance. You can have up to 16 texture layers per material spread across 6 channels. When you look at a graphics material with multiple layers in per channel, that's what it will look like. So you have the names of your layers, and the top one will be the first one that shows. All of the others below it will show based on the mask that you use and the different alpha settings that you use. So before we jump into the creation of graphic materials with Marc-Alexandre, I just want to go over the different channels that are available in Vortex. And to talk about channels and how they impact the way your model looks, we're going to use the buoy sample that is available with Vortex 6.7. So the 6 channels that are available are albedo, occlusion, normal, specular, gloss, and emission channels. The albedo channel is the basic color, the basic look of your equipment, your model. So in this screenshot here, we have a white albedo color, and you can see that our model is covered in a uniform white that is then affected by ambient lighting and shadows. If I switch that albedo color to red, it will be covered with a uniform red. This can be used to quickly quickly add color to models, but the most likely scenario is that you're going to be using a albedo texture as the base of your model. So in this case here, we've applied the main texture we have on our buoy, but you can see that it looks flat. It doesn't reflect the environment. It looks better than with the base color, but it's not as sophisticated and as immersive as we'd like. So we're going to look at the other channels and how we can use them to create a better model. Second channel is the occlusion channel. The occlusion channel defines your model's self-shadows. Now, that is shadows that are applied to your model to give it more volume, but they are not created by ambient lighting. Now, if we look at with just an albedo color, this is what our model looks like. And you can see that the edges are much too well defined. They're too sharp, and they really provide a feeling of flatness. If we add an occlusion channel, then we can start defining softer edges here and providing it a bit of a better sense of volume. Now, it's very evident if you compare them side by side which one looks the most realistic, even without further textures. With just a white albedo texture and a occlusion channel, already see that this is a step in the right direction, and it provides much better feeling of how your model is from a volume perspective. I've mentioned in the albedo channel section that we have a uniform look here with an albedo channel, but we also have a very flat model. I mean, we had one main cylinder that was a perfect cylinder. The real buoy, though, will have variation in its volume. So there's two ways you could create those variations. You could create different polygons, which will affect performance, or you could use the normal channel to provide the volume variations to your model without changing its geometry. So if you look here, we have a seam, a ridge on our cylinder that, as you remember, is not there. The normal map will affect the way light is reflected, in which direction it goes, and if light is reflected at all by a specific portion of the model, to provide a visual impression of volume that is not there. So this is still a perfectly smooth surface, but because we've added a normal map, it looks uneven. The next two channels, the specular and the gloss, are usually used together to define how your graphic material reacts to ambient lighting. The specular channel controls the intensity of how your material reflects ambient lighting. If you move it up, as you see, we reflect more of the ambient lighting, but if we were to move it down, only the most powerful light sources would be reflected on our model. Now this, combined with the glass channel, provides you with a lot of control. The glass channel defines how evenly or how precisely the light is spread on your model. So as you see in this loop here, if we increase the gloss level, then the light spreads less evenly until it becomes really one pinpoint of light. The last channel, the emission channel, will make your model and parts of your model self-lit. What we mean by that is easiest to explain with an example of a city building. So if you look here in our model, we have windows that have been set up that if it were during the day, they could reflect the environment. There is light coming in, and you could make it look like a glass material. But at night, they are flat and they don't reflect anything because there is no ambient light. Now, in a real city environment, there would be people in some of the buildings, in some of the rooms, so you want to have some lights in them. You could put light sources behind them to simulate light, but then it would affect performance. What you can do is use the emission channel to make them self-lit and make them appear as though there is a light source inside. Because it's a channel that only affects the model you're applying it to, it will not send light into the environment, and the lights of this building will not be reflected on other buildings, but it provides an approximation of light sources that will make it look a lot more realistic than having just a flat black building. Now you apply graphic materials to graphic nodes, and if you want to apply graphic materials to a graphic node, that graphic node also needs to have a graphics geometry, because if you don't have a graphics geometry providing the visual volume of your model, then you're not going to be able to unwrap your graphic materials to it. We're going to now look at how you can create graphic material with Marc Alexandre, who will create some basic materials and then rebuild the buoy sample that we've just looked at. Marc Alexandre.
Thank you, GP. So what you're seeing on the screen is the material library, which is a sample that we will be providing with Vortex 6.7. It includes over 30 different preset graphic material for a variety of real-world materials, such as metal, plastic, foliage, and so on. So I'm going to use the graphics in this gallery to show you how to assemble a new graphic material. So the first thing we're going to do is that we're going to create a new sphere, and then we're going to grab that sphere and we're going to move it into position, and we're going to center it like this, and we don't need the graphic material. So now the graphic material, there's no graphic material associated with this sphere, so it's just a blank node. So we're going to insert a new graphic material, and we're going to associate it with the node here. So now I've got a blank material to work with. So the first thing I'm going to do is that I'm going to put a texture in it. So let's just say we want to put a mud texture. So I'm using the filter here to show me what's available in the texture department. So we've got a texture for mud here, and I now have an albedo for mud. As you can see, it's very flat. So if you look in the preview panel, you can see it applied to a cube. You can see it applied to a plane. You can even see it applied to a shape that will allow you to check for seam, and you can add a background if you want to see it better. Let's go back to this. It looks nice, but it's kind of flat. So we're going to want to add a mask to it. So we're going to go into the albedo in the mask texture. So let's check what we have as a mask. So we're just going to put a mask on it, like this, and it sort of creates a mottled effect on it, which is not bad, but it's not quite what we want yet. So I want to have a mix of grass and soil, so I'm going to put in the same channel as the mask, I'm going to put a grass texture, and this gives a mix of mud and grass, which I can control with the factor and the layer. But it still looks kind of flat, so I'm going to want to add a normal channel to it. And then we go here, we go into the texture, and in 2K, do we have a normal? Yeah, we have some normal map that we can use. So we're going to grab one for gravel, for example. I'm going to apply it, and now it creates a sort of 3D effect to our graphic material. And if I want to, I can change how hard the normal map will be applied, and that gives us a really nice looking natural material, and that you can see it in the preview panel as well here. So that was a graphic material. Now we're going to try and, we're going to open a new graphic gallery, and we're going to import a model of the buoy that we saw earlier, and we're going to apply some texture to it. So right now the graphic material is plain, it's kind of empty, so we're just going to put it to white. So now we've got just the plain basic model here. So I need to add some texture to the models. So I'm going to go into the sample, and I'm going to locate the albedo, and I've got now my albedo. As you can see, it's a flat texture. There's no shadows. There's no details on it. It's like a water painting. So I'm going to go into the material, and I'm going to apply the material to the albedo. And there we see it. So we've got this, and now so we're going to add some specular and gloss to it. So let's go see and add more texture for specular and gloss, and we're going to add them here. And then we're going to drop it into the correct channel here and here. And now we've got a gloss effect added to it. So first we need to activate the specular texture. So you can see in the preview panel how it appears. So now we see it better. We still have a normal channel to add to give it some volume. So we're going to go into texture. We're going to insert the normal texture here, like this. And now we've got the normal. We're going to go here, like this. And we've got now the normal has been attached to it. So if I wanted to, I could increase the factor here to have more bumps, or reduce it as I need it, like this. So I've got it here, like this. And finally, I want to add a texture for ambient occlusion. So I'm going to add it here to the model so I can see it in the preview. And the ambient occlusion is going to go into this new channel. So I'm going to use the ambient occlusion here, and I'm going to apply it to the model. It doesn't quite work. So we're going to go into, did I add I'm sorry, I added the wrong material. So let's go back to this and delete it. And let's check the ambient occlusion. And it doesn't appear correctly because it's on a different UV set. So I go back to the texture. I change the UV set to 1, and now it appears correctly. The reason why we're using a different UV set is that the seams are not placed at the same location because we don't want to see them. We want the seam to be placed in the crease between the various parts. So now we've got this, and now we've got all our texture put together. I also activate the environment reflection so that the sunlight will reflect in it. And then I put some sunlight in it so that we can see what the final model is going to look like in our scene. And then we can just play around with the time of day so we can see how the model will appear at different time of day. We can also do this with other things such as terrain. So I'm going to use a construction site to give you an idea of what it looks like. So let's put some sunlight in this. Go back to the ground level, like this. And the graphic material that we've used here are quite big. So what we did is that we layered a number of texture to create the different effect on the ground. So this one is angled at 60 degree, and this one is angled at 0 degree, and one over the other creates this effect. And new in 6.7, we'll be able to use the graphic gallery as a terrain. So we just open a scene. I'm going to add a terrain, and I'm going to use this. The graphic gallery of the construction site, like this. And now my terrain is the graphic gallery that we had before. So if we open the graphic gallery, it's possible to modify it like this. For example, if we select the just the house and we don't need them, I can remove them in the graphic gallery, go back to my scene, and they're gone from the terrain. And if we check the collision geometry, the house are gone indeed. And so that way you can use the gallery to modify terrain according to your need. Back to you, GP.
Thank you, Marc-Alexandre. So now we've imported our model, we've cleaned up its structure, and we've created our graphic materials and applied it to it. What's left is basically to take our gallery and use it as the starting point for our mechanism. So how it works is basically very similar to how it worked when you use the 3D model directly in the 2D mechanism. And that is, we import a graphics gallery and then you use its different nodes as the beginning point for your parts. Now, one difference is that there will be connections that are created directly between the nodes and the parts automatically as you create the parts. It will look something like this, and the default connection list will be called skin. Now, all of these are the links between the different parts and the different nodes that if they don't exist, you would end up with a disconnect between your dynamics and your visual. As you see in the image here, your visuals are unwrapped on a graphic mesh, whereas your dynamics are applied on collision geometry. So the connections will make a direct link between both. Now, the graphic gallery provides you with the ability to do editing in parallel. So that means you can work on a mechanical dynamics aspect in the mechanism while an artist could fine-tune the graphics in the graphics gallery. One thing that you need to be careful about is that if you edit nodes or parts, then you could break the existing connection. And if that happens, we'll have to recreate those connections. So we're going to wrap this up with a final demo in which Marc-Alexandre will show how to import the graphic gallery in a mechanism and how to begin creating part. Marc-Alexandre, here you go.
Thank you, GP. So on screen you can see the graphic gallery of a forklift model that we're going to include in Vortex 6.7 as a sample. It uses all the new feature of the graphic gallery for reflection and gloss and normal map and so on. It's very useful as you'll be able to see. So you can see how the reflection of the tires is different. And if we go into machine material, you can see an example of a complex graphic material that's been used to recreate the look of our machine. And it also allows us to do stuff like change the color, for example, of the forklift according to our need without going back to an artist. In this case, what we want to do is create parts from this graphic gallery. So we're going to open a new mechanism. And in this mechanism, we're going to insert a graphic gallery from our files. So we're going to select the forklift graphic gallery. So now we have it opened up. And I want to add an empty assembly to receive our part. And now I'm ready to go. So opening up my gallery, note that I can't affect my gallery. So basically, if I want to make changes, I need to double click on the gallery, which will open it up. And any change I make there will be immediately reproduced inside the mechanism. So what I want to do here is create parts. So I'm selecting a node, in this case the rear tire. The rear tire is composed of two nodes, an inside cap and the tire itself. Now the inside cap is a child of the wheel, so I can ignore it for now. I'm just going to do a collision geometry around the wheel. The cap is inside. It doesn't matter if I don't do a collision geometry for it. So I'm going to select the tire here. I'm going to create part, and then I'm going to confirm the assembly I want to use. And now a part has been created for the rear tire. So what I'm going to do next is create a collision geometry. So it's offering me a number of primitive as well as a convex mesh decomposition process. But in this case, I know it's going to be a cylinder, so I'm just going to use best fit. So now I've got a collision geometry being generated around my wheel. And now I can open the wheel, and I still have access to my 3D model node here, though I can't affect it, but I can see it. I can assign material to my my collision geometry. I'm going to save it, and I'm going to close it. You can also let's do another one. This time I'm going to take the body of the forklift, and I'm going to create part in assembly. So now I've got a part for the machine. I'm going to save it again. I'm going to open the machine part, and now only the graphic node associated with that part will be shown in your 3D viewport. So you can insert your collision geometry here. So for example, if I put a box here, and I move it, it's going to be reproduced at the mechanism level. So you go into your part, and using the various primitives, you can do very detailed collision geometry according to your graphic node that you can see here as a reference. And you can also hide the node if you don't need it. And you continue doing this, creating parts based on your nodes, and then in the assembly you'll add your constraint, add your logic, and in the end you'll get a workable mechanism. Back to you, GP.
Thank you, Marc-Alexandre. So today we've seen how you can start directly from your external model, 3D model or CAD model, doesn't matter, and use a graphic gallery to fully optimize it and control the visual rendering of your model directly in Vortex. Now, graphic gallery really provides with editing tools that were previously not available in Vortex, and that allows artists to fine-tune models directly in the Vortex rendering engine, which means that instead of going back and forth as you see the rendering, then you can get to a very precise and very striking look directly in Vortex. So this concludes today's presentation. Now we're going to open the floor to questions, which you can send us using the right-hand side question box. You can also download the presentation. If you are leaving us, I'd just like to thank you for joining us for today's webinar, and I'd like to invite you to July 7th Vortex University webinar, No Permits Needed, which will cover Vortex vehicle system. So just we'll send a follow-up email with the direct registration link in the next 2 days. So again, thank you for joining us today, and we hope to see you next month.